All right, this is going to be geometry, lesson 2-7. We are on side, angle, side, and side, side, side congruence theorems, and those are the abbreviations. So we are on standard F. What is standard F, class? Say it louder, Steph.
Congruent triangles.
Yeah, and just in case the microphone is not picking that up, congruent triangles. All right, so I want to ask, what is congruence? What does that mean to you? If I say, are these two things congruent? What am I asking?
They're the same.
Yeah, exactly. So another word for congruence, so maybe I'm going to do this in quotes here. This means the same. So every time I see congruence, maybe you want to just change that for the word same. Congruence is a little bit more specific in mathematics. So we don't really care about rotation, so we'll make a note here. Don't care about rotation. So when I say same, there are two things that need to be the same. We'll say one, maybe I should make it a little bit bigger. There are two things that need to be the same, 1 and 2. Congruence means that you have the same side lengths. And it also means you have the same angles. If those two are satisfied, then you have congruent lengths, congruent triangles, congruent shapes. So today, and in this entire lesson, we're only dealing with triangles. So I need to figure out how to tell if triangles are the same. Do they have the same angles and side lengths? And there's an easy way to do that, and that's using some of our congruence theorems. So let me start by just showing you a picture. So we'll call this example. So the whole point of these next few lessons is I give you only a limited amount of information, and you're supposed to be able to kind of jump to a conclusion using our previous knowledge about vertical angles, about alternate interior angles, stuff that we've already been studying. So let me just give you a simple triangle, two triangles actually. So draw one triangle and draw another triangle. They might be the same, they might not be the same. And I will only tell you that we have the same side length here and here. Are these two triangles congruent? Do we have enough information already to know that these triangles are congruent? Fiona's shaking her head, Steph is shaking her head. Everyone's saying no. All right, and I agree with you. There's not very much information. So what about now? If I say that these two triangles are the same, or not, they're not the same, but these two side lengths are congruent. I'm saying that our first side length here and our second side length here are the same, bottom and bottom are the same. Now are these two triangles the same? Still shaking our heads, no. All right, what happens if I do this? And maybe it's a good idea to maybe give us a counterexample. Why does this one not work? Why does having two sides, why is that not enough? Can we picture a counterexample? No? So don't draw this, but this is what I want us to be thinking of in our head. But say I have a side length of 1 and a side length of 2, and then this can be whatever it wants, because we haven't labeled these two. This can be like 7. It can't be 7 because of the triangle inequality theorem. We'll say that's, I don't know, 2.5. And then another way of drawing a triangle where these two side lengths are the same is having a side length of 1. Okay, let me try drawing this a little bit better. Side length of 1, a side length of 2, and then this side length of, I don't know, 2.7. So that's a counterexample, because we still have two side lengths that are the same, and the triangles are definitely not the same because I have different side lengths for the remaining side. So then the question becomes, what happens, and do draw this in your notes, what happens if I have 3 equal sides? Is that enough information to know that they're congruent? So shake our heads again. It's okay to be wrong. Just say, don't think there is, or maybe. So if you decide that there's not enough information, like I did down here, you need to be able to draw a counterexample either on scratch paper in your head, or you can just do it in your notes. And if you assume that they are the same, be ready to explain. Either way, you're going to have to explain why they are or are not the same. So go ahead and shake our heads. Do you think that these are congruent triangles? Shake head yes or no. All right, so we have a lot of blank faces. So let me get rid of all of this stuff down here. Okay, that is a little bit too big of an eraser. Let's make our eraser a little bit smaller. And again, the eraser lags, of course. Okay, I will tell you that this is enough information, but I need to make sure that we understand why. So we can say these two triangles are congruent, but why? I mean, obviously you can just say, oh, well, we're studying the side-side-side congruence theorem, and you have a side, and a side, so it might have something to do with that, but that's not enough. We need to really get to the root of why. So I don't remember how many lessons ago it was, but there's something along the lines of, if you have sides and then you take the opposite of that side, that angle will be proportional to that side. Do we kind of roughly remember that by maybe nodding our heads? Something about angles being proportional to the sides, so I can tell you which angle is the biggest if I gave you all the sides. So if those angles are proportional to the sides and I gave you the same side, then the angles should still be the same angles because of the proportionality. So I definitely have all side lengths. If I come back here to my definition of congruence, I have same side lengths. I could give myself a check, but I'm not sure about the angles until I remember that angles are proportional to the sides. So because I hit these two parts of the definition, I can see that these two triangles are going to be congruent. And then the full sentence is, they are congruent by, and you can say side, side, side. And that's a fancy way, or a short note way of saying they are congruent because of the side, side, side congruence theorem. I don't want to write out the whole thing, so I just say by side, side, side. All right, let's see if someone can regurgitate what I just said. Somehow using our definition of congruence, someone explain why these two triangles are the same. I'll give you guys 10 seconds to redigest, think about this. Why are those two triangles the same? All right, now talk with someone around you. Chris, you can go jump and be a group of 3. Talk with someone around you and explain your reasoning. See if you guys have the same reasoning, or see if everyone is confused. So Chris, join another group. Stand up, physically move over, go talk to Fiona and stuff. All right, so I heard Andrea and Eva talk. So do one of you two want to share what you were talking about?
You said that since all the sides are the same and all the angles are proportional to the sides, they're congruent.
Okay, yeah. And then Fiona, Steph, and Chris, did you guys come up with something similar, or were you still confused on why they're congruent? Representative?
The same thing.
Same thing? Okay, so you guys were able to regurgitate it? All right. So, and then the next example is going to be, so I guess we could have labeled this side, side, side in our notes. I want to talk about our last theorem that we want to talk about, which is side, angle, side. All right, so side, angle, side says that you need, well, we can kind of break it down here. Side, angle, side. The order of the letters matters, and maybe we should make a note over here on the side. Order of, I should say, these letters matters. It's not enough to say I have two sides and an angle. You have to say it is a side and then an angle and then a side. So SAS, in our notes we can just say sides congruent, or not sides, but side, singular, side congruent, angle congruent. And do you guys know the symbol for congruent? So instead of writing congruent here, I'm going to write the symbol for congruent, which is an equal sign with a squiggly mark on the top. Then I'll say side congruent. It makes our notes go faster, and I can write more with less. And I can make a note on the side here for those of us that just want to copy down the PDF. So this is the symbol for congruent. All right. So let me draw two triangles, and I'm just going to use my triangle tool. I'm going to make some random triangles. And you guys, you can write this down. It's up to you. I'm going to do a few examples. You need to write one of them down. So let me tell you this. All right, my question for this picture is, can I use side, angle, side on these two triangles? I'll repeat the question. Can I use the side, angle, side congruence theorem on these two triangles? It's a yes or no question. All right, do a thumbs up, thumbs down, so that everyone has to hold up something. Thumbs in the middle if you're not sure. All right, Steph, talk to me about why you said no.
Because they have different standards.
Because they have different side lengths? Can you explain that a little bit more? Maybe I can label these so you can talk about the triangle more. A, B, C, D, E, F. Which two side lengths are not the same that you're talking about?
The
The whole
whole thing.
thing?
Yeah, because that one's smaller.
Okay, so I understand where you're coming from. I'll say your eyes lie again just because I can draw the triangle any way I want, but as long as I have the correct notation on here, you have to only assume the correct notation. So Andrea, you had your thumb down as well, didn't you? Why did you have your thumb down?
Because it doesn't follow the order of the letters.
It doesn't follow the order. Can you explain that a little bit more?
Like it's angle, side, angle. And we don't know if the other sides are the same.
Okay, yeah. That's correct. The correct way of thinking. So in these two triangles, I have an angle, a side, and an angle. So if I had some theorem, and this is tomorrow's theorem, angle, side, angle. If I had some theorem that worked for angle, side, angle, then I could use that. But I don't have that. I'm looking for a side, and then an angle, and then a side. And I don't have that second side. So no, we can't tell if we can't use the side, angle, side theorem. But we can use a different theorem that we haven't learned yet and prove that these are congruent. All right, so let me try doing something else. I'm going to try erasing this really quick. Okay, with these same triangles, let me do a different example. What if we did this?
Do we erase that too?
What's that? You have to copy one of these examples down. If you copy that first one, then you're good, and you can say this one you can't use side, angle, side. Let's try this one. Can we use side angle side to prove that these two triangles are congruent? So don't answer immediately. I'll give you guys 10 seconds to think. The lisp. Talk with someone around you. Come on, Chris. You can talk with people around you. Just sit at the corner next to Fiona. That way you don't have to keep getting up. Move your notebook and everything to the corner so you don't have to keep getting up. There you go. All right, someone talk to me. Quiet raised hand. Yes or no? Eva, go for it.
Yes, because it goes by the order, and we know. Wait, no, just kidding. It should come in.
You changed your mind? Why'd you change your mind?
Wait, just kidding.
Just kidding again? You're going back to yes?
Yeah.
Why yes?
The angles are proportional to the sides, so we know that that side's equal and that side's equal. And those two are equal, but the one dash thingy, and then the ones with the two, so.
All right.
Something like that.
So you had some interesting logic there. What I heard was that the angle was proportional, so that's how you're trying to get this side length. And then you saw all three sides are the same after that. So that's correct-ish. We have to be careful because, and I'll give you an example of why we have to be careful, but more or less, I'll give you the half point. But I think you also said something along the lines of the order was correct.
Yeah.
That we had a side, and then an angle, and then a side, and then the same side, angle, and then the same corresponding side. And that's what I really want to care about. So that answer I give full credit. You have the correct order, side, angle, side, and it was the same measurements. That's good. And remember, we don't care about rotation. This was rotated a little bit, but we don't care. They're still congruent. All right. We have to be careful about the order because, and maybe I should find something online, and we can talk about this a little bit tomorrow since I'm kind of not prepared. But if I have just a side, and then an angle, then I get in trouble. And I think I'm just going to leave it at that, and I'll show you an example why that gets us in trouble for tomorrow. Just trust me until tomorrow, and then we can actually study some more. So side, angle, side, and then we're good. Can I give you guys a hard example to see if you guys can get it?
Sure.
All right. So let's go to a new slide here where I copy this and this. All right. So a harder example. Please do write this one down because I think everyone deserves to try this one out. So give yourself two lines that are parallel. And then make two transversals to make an X through your picture. And we'll go ahead and label this thing. So this is going to be point A, B, and C. It's going to be D and E. All right, I will tell you the following information. I will tell you that DC, and I'm going to write this out so you have to annotate it. DC, line segment DC, is congruent to line segment CB. And I will also tell you that line segment AC is congruent to CE, to line segment CE. And then the question becomes, okay, I can spell here. are, or maybe I should say is, sorry. We'll make it shorter. I was going to make a long sentence, but we'll say is triangle ABC congruent to triangle EDC. All right, I'll give you guys about a minute to work on this one. I would start by marking up the diagram and then figuring out if you can use side, 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 or side, angle, side. You already have an answer? All right, let everyone else think. Once you have your answer, you can raise your hand to let me know, and then you can put it back down. Okay, Fiona's got the answer. Okay, Steph has got the answer. All right, Eva, what's the answer?
They are congruent.
They are congruent. How'd you get that?
I used the side angle side.
Can you get stand up and point at the board? What happened?
You said these two were congruent and these two were congruent, and then I used vertical angles.
So you said, see, those two are congruent, and then these two are congruent like that?
Yeah,
Okay, and then what did you mean by vertical angles?
like these two. These
Those two angles. Okay, so let me mark what you're pointing at. These two angles are congruent.
Yeah, and since the angles are proportional to the side, I put that these two sides were equal.
Yeah. So again, be careful because yes, we do know that these two sides, DE and AB, are congruent. They are the same, but we only know that after we apply side, angle, side. So the answer here is yes by side, angle, side after we use vertical angles. And then from that, then we can say yes, now DE is equal to AB. But you have to be careful about that because sometimes you're given it in the wrong order. And I want to give you a different type of problem that gives a trick, but I'm going to do another trick like that tomorrow. Okay, last example, and then we can do the homework. Actually, what time are we at? We get out of here at 10:06. Can we just do something really quick? I'm not even going to do the example. I'll just tell you what to be wary of. So another example. If I have two triangles, give yourself two triangles and label them A, B, C, and D, E, F. Go ahead and give a tick mark for A, B, and D, E. And then this is where the trick comes in. So be careful of this. Double tick mark for BC, double tick mark for DE or DF, and then triple tick mark for AC, triple tick mark to EF. Slightly in a different order. The order here matters. So I'm going to do the bad one first. Bad. And this is just how to write congruent statements. Maybe I should label that. Congruence statements. Bad is to say triangle ABC is congruent to DEF. The good is to say triangle ABC is congruent to EDF. Oh, I should have done triangle here. Triangle EDF. Triangle EDF. You have to match up the side lengths with the order in which it goes. So AB is equal to each other. So AB, are equal to each other. Sorry, AB and DE. So it should go AB and ED. And then from there, the next side length that I chose was BC. BC is 2. So we have this 2. Maybe I should do a different color. We have this 2 here for BC. So there's BC. So those 2 should correspond with DF. DF. The second and third letters are the second and third letters. In this case, BC corresponds, I said, with EF, and that's not the case. Look at EF. EF is not quite the same thing. EF is 3 lines, not 2 lines. A correct congruent statement will have all 3 letters in the correct order when I write out the statement. So just be careful of that. All right, that ends the notes. Go ahead and write your summaries.